Hi, welcome to Pencil College. In this video, we'll be moving on to chapter 7.1, the midpoint of the line joining 2 points. Okay, so here are the lesson objectives. We want to learn how to find the midpoint, distance, and gradient of a line segment and apply it to solve problems. So first and foremost, let's look at the midpoint formula. Given that the coordinates of 2 points are A and B, the points A and B are x1, y1 and x2, y2 respectively, let us find the midpoint of AB. So first and foremost, what is the meaning of the word midpoint? Okay, so suppose I have any line, let's call this line AB. So we have line A and B. Then the midpoint of AB is somewhere over here, which divides the line AB exactly by 2 or exactly by half. Okay, so let us look at this diagram over here. So this point would be point A and this point would be point B. Okay, so point A and point B. So the midpoint formula, okay, is given as x1 plus x2 over 2. So x1 is the x coordinate of A and x2 is the x coordinate of B. Okay, and then we take this sum divided by 2. Okay, and that will be the x coordinate of the midpoint. So this point over here, okay, let's call the midpoint point C. Okay, so the x coordinate of C will just be x1 plus x2 over 2. Okay, so let me just highlight it over here. Okay, on the other hand, the y coordinate of the midpoint C, okay, will just be y1, which is the y coordinate of A, plus y2, which is the y coordinate of B, divided by 2. Okay, and there you have it. This is your midpoint formula. We won't be going into the proof in this video. Okay, probably I'll do it in subsequent videos. Okay, we'll just learn how to apply this midpoint formula. Okay, so let's move on to talk about the distance formula. So similarly, if we have points A and B, if we have coordinates of points A and B to be x1, y1 and x2, y2 respectively, then the distance AB, which is the length of line segment AB, okay, let me just draw it in red over here. So the red color line here represents the distance of the line segment AB. Okay, so in order to find the distance, let us first plot it onto a piece of graph paper, which is essentially my xy Cartesian plane. Okay, then we realize that we can actually find distance AB using Pythagoras theorem. Okay, but before we do that, we must first drop a dotted line over here to make a right-angled triangle. Okay, so if we were to call this point over here point C, then you realize that by Pythagoras theorem, so let me probably write this in black. By Pythagoras theorem, the distance AB squared, okay, is equals to AC squared plus BC squared. And therefore, AB is just the square root of AC squared plus BC squared. Okay, and then moving on, let us look at how we can find distance AC. Okay, so I shall use a blue colored pen over here, or rather a green colored pen over here. So distance AC, which is being drawn in green now, okay, distance AC is in fact the x coordinate of C, which is x2, minus the x coordinate of A, which is x1. Okay, so therefore AC is simply just x2 minus x1. Okay, therefore AC squared is simply x2 minus x1 squared. Okay, and you realize that if I were to factorize out a -1 from this expression, let's say I do this, so -1, okay, x1 minus x2, and if I were to square this expression, I will end up with x1 x1 minus x2 squared. And therefore, you see that this expression, okay, let me just highlight this over here. This expression is the same as this expression. Okay, so just to show you that the formula can be written in two ways. Okay, later I'll write out the other form. Maybe I should just do it now. Okay, so over here, this can also be written as x2 minus x1 squared plus y2 minus y1 squared. Okay, so there we have it. Okay, so just now we were saying that our AC, okay, so AB is equals to square root of AC squared, which is x1 minus x2 squared plus BC squared. Okay, now let us explore what is BC. So maybe perhaps for this I shall use a blue colored marker or blue colored pen. So BC, as you can see from this blue line over here, so BC is equivalent to y2 minus y1. Okay, and therefore BC squared is equals to y2 minus y1 squared. And similar to the proof that we did over here, okay, highlighted in yellow, this is the same as y1 minus y2 squared. Okay, so BC can be written as y1 minus y2 squared. Okay, so if I were to look at what I've just written over here, okay, it's exactly the same as the formula that we see on the top of the screen. Okay, so that's the distance formula. We'll be looking at some tangible examples later. And finally, we have the gradient formula. Okay, the gradient formula is essentially your dy dx, okay, or something that is called differentiation, which you will learn perhaps further in your course. Okay, you can also watch our differentiation videos if you want. Okay, but to put it in simple layman terms, okay, the gradient of 2 points, let's say A and B, is simply the rise over here divided by the run. Okay, divided by the run. So the increase, or rather the change in y, okay, the rise can be said to be the change in y, okay, divided by the run, which is the change in x. Okay, so the change in y is denoted by the y coordinate of A minus the y coordinate of B. So let me just highlight it over here. Y coordinate of A minus the y coordinate of B divided by the x coordinate of A minus the x coordinate of B. Okay, and there you have it. This is the gradient formula. Okay, I hope you have enjoyed this short introduction video on the midpoint, distance, and gradient formula. Okay, so I'll be doing more tangible examples in the next video. Okay, so for more videos, please log on to pencilcollege.com. I'll see you in a while.